Now then, if you remember, this is a Prius nickel metal hydride battery made up of 28 cells, each cell a nominal sort of 7.4-ish, 7.2 volts. So, and there are 6 nickel metal hydride cells in each one of these individual packs. Right, okay, now a while ago when we were commissioning this, we did a drop test with Lee, and what was it, we went down to 47 volts and it took 14 minutes with a drop test of 10 amps. There's the details. But this battery had only been in circuit for a couple of weeks. Since then, the low cells, I have actually charged them up a little bit with the bench power supply individually, but we haven't done any drop testing since then. And I thought, there's all the figures that we had the first time. I thought what we really need to do is to do an individual block drop test. So to that aim, what I've done is, let's whiz around. First of all, we've got 2 meters set up. The one on the right is set to DC amps, and the one on the left is volts. So volts is wired directly across the battery when I connect these ends to the bolts on the end of there. Hopefully you saw that. The amp side, we are going through a length of nichrome wire. Now I could have used Ohm's law, as in this book here, Wind and Solar Electricity, recently republished, available at Bimble Solar. So I could have used Ohm's law that's defined in there and the Ohm's wheel, etc, etc, or I could have just experimented, because resistance is volts divided by amps, V over I. Okay, but anyway, what I did do is I experimented, and this bit of nichrome wire here, I think it's something like 6 amps, which is fine. Yeah, we shall see when we actually do the drop testing. Now these are 6.5 amp hour batteries, so a 6 amp load would be alright. I'm going to do a couple of them, and then I don't expect you to follow them all through, but number 11 and number 13 were a bit bad. Okay, so, and then after that I will do it off camera and we'll just see how we get on. Don't worry about the polarity and all that lot. So I'm just putting, I suppose you need to see this really. Let me just come round here. On the end of each block there is a nut, yeah, which is a connection. So there's a nut that end and a nut that end. So I'm going to connect these two. Let me just zoom out a bit. So that and that goes to that end and that goes to that end. Okay, right, so let's just go around to here. Yeah. So number 1 is 4.8 amps and we're on 7.3 volts. Okay, so it's holding the voltage up with that load. That's fine. Number 11, which was a not very good one, 4.8 amps, 7.3, 2, 1. It's sort of going down. Yeah, so it's not holding the voltage, but it's not dropping rapidly. Number 13, 4.8. Right, and number, yeah, you see, number 13 is a bad cell because that voltage is dropping rapidly. Let's try a different one. Let's try number 17. Where are we? Yeah, you see, it's going down a bit, but it's not bad. 4.9 amps and it's 7.5. It's bouncing around. Yeah, so it looks like number 13 is a bad one. I'm going to go through all of these and record it all, and then I will get back to you. But number 13 is definitely, that's it, that needs to come out of circuit. Right, just here's another little interesting thing. Number 10 is a good one. Okay, you've got to get good contact. Okay, but look at the amps, 5.02 and we're on 7.5, and it's all going down slowly, but we've got a reasonable load. Yeah. Okay, so look, what's another one? Let's do number 13. Where's number 13? Here's number 13. Yeah, we're on 4 point, and the amps are going down and the volts are going down. Yeah. Okay, so that's going down fairly rapidly. So number 13 is definitely not really up to it. Oh, and of course, when you have a multimeter on the amp setting, before you switch it off, swap it back. Otherwise, it's blue smoke dragon time next time you use it. Right, let's have a look at the test results. Okay, I think we can just about get that in there. Yeah. Right, screwdriver as a pointer. So 4.8 amp drop test per block. Those ones are alright, they're holding steady-ish. Yeah, not so bad. Here, 11 volts are going down and the current. All those three are not very good. And number 15, which was a low one, and it had been boost charged, but 7.3 and going down. So these lot are alright. Yeah. Interesting, number 26. The original was 6 volts after 14 minutes at 10 amps. But this time it's 7.5 on the drop test and it's alright. So it seems, oh, those two are all right as well. So it seems to me that we have got 1, 2, 3, 4 duff cells, and we need to take those out. We've got, that's one pack. 7 to 14 is another pack. So in that pack we've got 3 duff ones, and then in the next one, 14 to 21, we've got 1 duff one. So we're going to either have to do some, take it apart, or do some cross wiring. And I think we'll do some cross wiring. We'll just take those out of circuit. So effectively, instead of having 4 packs of 7 cells, we're going to have 3 packs of 7 cells with a few duff ones just left in there and a couple of good ones. We'll just have to let them sit there. But that's how it is. You put a load across the battery and you check A, the current, and B, the volts. It's the volts dropping that is important. And of course we talk about volt drop and what have you in this book here, available at Bimble Solar. Catch up with you soon. Comments, discussion, love to hear what you have to say. It's the only way to test the cell in the end. You've got to initiate a load on there as if it was working and see what it does with the volts. Cheers for now.